Hi, everyone. Welcome to the Infrastructure Network. My name is Chad Smelzer. I'm your host. Today's guest is Damian Butters, who's the CEO and founder of TDRI. Thanks for joining me, Damian.
Thanks so much for having me on, Chad.
I appreciate you joining, man. I got some, you know, conversations with you prior to this, and we were talking about road condition assessment and all this good stuff. And yeah, I think what you're doing is innovative. So, what we want to do today is, talk a little bit more about you and like how did you get into the road condition assessment? Like, what was the start of TDRI?
Yeah, well, there was certainly no clear trajectory towards this actually happening. My experience prior to this was one other role, and it was an amazing opportunity. I spent nearly 20 years designing and building teams and manufacturing security and access control equipment. So we were in the vertical infrastructure industry. And I genuinely felt like we were providing a lot of opportunity to improve uh, the security for people and places with what we provided. But once that was sold off to PE and turned into a bit more of a worker factory, I decided that it was an opportunity for me to go out and find something else that was really a new way to look at solving a problem that was really going to have additional value to potentially the entire world and some really critical problems that the world needs to address.
So you went out hunting for a problem.
You know what? That's normally the opposite way that things should be done, but I think I did, and I actually ended up talking to one of my very good friends who had worked with a venture capitalist group here in New Zealand, and had amazing success and found a lot of synergy in working with them. And I approached them because I had a couple of ideas of my own that I wanted to bring forward. And they said, "Hey, look, we've got this technology that we've worked with Lincoln University, a leading university down here in New Zealand, on. And yeah, we've got a bit of a prototype, but we're not really sure how well it works. And yeah, we know that there's a lot of opportunity, but we need the right people to make this happen." Now, I didn't know that was going to be me at the time. I came on board to have a look at the technology and make sure it really did what it said it could do. And then start working with customers to understand what they really needed here in New Zealand. Throughout my career and as a technology designer and manufacturer, I've always found that New Zealand is a fantastic test bed for getting things done. We have what we call this number eight wire mentality here, in that we're very keen to try and get things done for ourselves and be as independent as we can be. And so we're quite open to trying out new Kiwi technology. And so we've had a great reception from a number of the civil engineering firms, and in particular the government, both at a national and a local council level here, try out what we've been doing and give us really good feedback so that we can refine what we're doing, so that we can understand how to make it better for everybody as we approach a wider audience with this.
So your background is engineer.
Yeah, that's right. So
Okay.
electronics engineering. So I was
Electronics
designing
engineering.
circuits and writing firmware for many, many years. And then for the last sort of decade or so, it's really been about building the teams and working with customers to make sure we really build the right thing.
So you're changing into a leadership role.
Yeah, exactly.
Yeah. Nice. And this is have you built startups before, companies?
So that previous company, there were four of us in a kitchen when we started out, and when we finished up, we had over 350 staff globally, and we had around 80 engineers in the R&D teams that I looked after. And I felt truly blessed to have the opportunity to bring those people on, work and grow together with them as everybody built their careers. We brought on a lot of people early out of university, and that was hugely successful for us. And that's the kind of thing that I'd really like to uh, repeat again in TDRI.
Yeah, that's awesome. So you partnered up with this VC firm, which you probably had
Mm-hmm.
connections with, and then they're looking for the solution to different problems. And then
Mm-hmm.
it sounds like, going into your current TDRI company, which is explain to us a little bit more about how you found, I guess, road condition assessment to be one of the problems.
Yeah. W&T, the VC firm, got together with Lincoln University and had a look at their portfolio of technology. So, this is a common challenge in that there's some amazing things that are developed as ideas at universities, and then the struggle is then turning them into real world, commercially viable applications. So the W&T team actually had a really experienced market research team take a look into the application. So the university had proposed everything from can we scan fields for agriculture through to can we use this to measure moisture content in wood during the kilning and drying process. So this was fundamentally a moisture measurement technology. What can we do with it? And so, through this research process and talking to a number of people globally, they focused in on this application in roading, where they found that there were a number of technologies to help understand what's happening on the road now, and those were primarily focused on what's on the surface. But unfortunately, without a jackhammer and I know they get perhaps a worse rap than what they might need to, a nuclear-based device, there's no other good way to measure the moisture content and what's going on under the surface of roads. And so that's where they saw a really big opportunity to make a difference. Versus some of those other situations where they might already have a few other solutions for measuring moisture that they're comfortable with today.
How many miles of road are out there?
Wow. If you're talking about sealed road, I think you're looking upwards of 6 million miles in the US alone.
Oh, wow. Okay. Yeah, I didn't do a lot of my own research before this, so
Yeah,
I
no
have some
problem.
numbers that I'm going to get into later. But that was 6 million miles, you said?
Yeah, here in New Zealand, say for state highways, we have a much smaller amount, obviously around 120,000 miles. And so we've scanned well over 20% of that these days. And it's been very interesting understanding the correlation there between what engineers are forced to speculate, because in reality, that's the way they've had to do this to date, and what's really happening under there.
So, out of this portfolio of opportunities, technologies out of the university, we discovered that there's a moisture technology or application that can be used potentially in different places. But then it sounds like you guys decided that the road market was a better market to approach. And what was some of the criteria behind that decision? Were you a part of some of that?
Criteria were around looking at the unique capabilities of this technology and how they could be applied in each of those possible scenarios. So, a couple of the key points through the development of this technology that they identified were that it could be used at very high speed.
Hmm.
So, the necessity of having many millions of miles of road and having to drive all of those to scan means you want something that can operate without interfering with the normal flow of traffic. Uh, and so being able to operate at high speeds means it can achieve that. And then the other situation is being able to measure to a fairly significant depth. So being able to set the system up in a way such that we can measure down to 18 or 36 inches under the surface means that it far exceeds what you might need for something like drying 2x4s in the kiln system, but is very applicable to something like roads where you can easily have 30 inches of construction under that surface.
Yeah, those are what kind of speeds are we talking?
Well, we got to go out on the Indy 500 Speedway actually while we were over in Indiana, and I think we would have loved to be able to test the maximum 140 mile an hour theoretical speed that we can do, but unfortunately, on that day we weren't allowed to go quite that quick. But yeah, full traffic speed was always the key here, so we've maintained that throughout creating the.
So 55, 65, typical speed, 75.
Yeah.
Piece of
I
cake.
think
Got it.
technically you're supposed to stick to 10 miles under the speed limit when you're towing a trailer. So that's what we
Oh,
do right now.
good point. Good point. All right. So let's talk about the technology now. It's driving at a fast rate of speed. There's got to be some type of mechanism that's like, how is it? Is it laser? Is it like, what is it that's actually grabbing that data?
That's a really good question, and the most common assumption we get, and it's very reasonable based on the technology that's out there today, is that this is some form of GPR, of ground penetrating radar. Now, GPR has been used and is continuing to be developed for moisture measurement, but what we use is actually an extension of the tech that's in every standard soil moisture probe that's out there today. So that 12-inch steel probe that you'd insert down to the ground, that is using what's called time domain reflectometry.
Hmm.
And what the fantastic professors and team at Lincoln University figured out is a way to use that same core technology of firing pulses along a medium, but instead of needing to physically insert that probe, they developed an antenna system that allows that same technology to work wirelessly or non invasively. So this antenna system is placed down close to the ground surface, and it then creates an electromagnetic field that's set up around that antenna, and that's what penetrates the road surface, and that's where the magic is in this technology.
That's really cool. I was going to say electromagnetic because that would make sense. Water's conductive. You're going to be able to do the if it can get the depth that you were talking about, obviously to go under that concrete, that's huge because
Yep,
you'll pull up all that concentration as the basically the data points within each molecule of water. You'll be able to grab all those points and pull back a consensus of how much moisture is where and you know.
exactly
I'm just
right.
kind of running through my brain real quick of what it might would sound like to me. But that's wild, man. That's really cool. And to be able to do it at standard speed, road speed, and grab that
Yeah.
kind of data, that's amazing.
Yeah, I'm not exactly sure on the numbers in the US, but there's been a lot of media in the last 12 months or so here in New Zealand around temporary traffic management. And we love to hate on road cones here, and we certainly don't like any disruption to our travel. So, what was discovered by the incoming government was that we're spending around 25% of our construction budget purely on TTM. And so I think that was a little bit eye watering to actually realize. And so the value of technologies and processes that can be used without slowing down the road, without closing it and diverting traffic is pretty significant.
Yeah, I see this as a great tool to just get an idea of where. Well, we're going to talk about that. We kind of talked about the solution, but I
Mm,
guess what's the problem, right? Well, the problem is, and I'm just going to run it through my analogy of how I think about it. And obviously, Damien, correct me when I'm wrong here. But the thing is the moisture under the roadway creates the sediment, like an opening underneath the concrete. It creates that cracking. It creates that void. It creates that opening. The more moisture, the worse conditions because it keeps eroding, right? And then that forms as the concrete or the asphalt over top of it, whatever, starts to cave in. It creates that crack, which creates the pothole. Am I wrong?
you're absolutely right. So yeah, there's a number of mechanisms, but
Yeah.
water really is that number one hidden demon, that hidden killer lying under the surface. So here in New Zealand, we, except for a couple of areas down the South Island, don't really get frost heave. But that's one of the major things that you would see across significant portions of the US, right? So that moisture freezing, turning to ice, actually expanding, creates enough pressure to lift that entire road surface up. So literally blowing it out from the inside. And we down here where we have hotter temperatures and same in the hotter climates of the US, you end up with that moisture actually getting hot enough from that melting blacktop on top to turn to vapor and expand. And so it's actually creating that same pressure from underneath as well. And I'll have to share a link to you for you. There's been these amazing videos I've seen of what's called flushing, where the asphalt binder actually gets squeezed out like toothpaste from underneath the surface. You can literally see it bubbling out from underneath from that
Wow,
water vapor pressure.
that's crazy.
Mm, mm.
That's that's a lot. So I'm thinking, okay, well, all right. So if the issue is moisture, right, during the construction phase of laying down a new road, or are we talking about like asphalt on top too? Because is that an issue, like laying asphalt and there's moisture underneath it? Are we just talking about moisture underneath the concrete base?
Oh no, we're absolutely talking about moisture under the asphalt. So that's a
Okay,
huge problem. Yeah, that I mean that
got it.
really creates the issue itself, and this is so often the problem, in that the moisture is not addressed, and then this beautiful pristine layer is added on top, and it just further traps that moisture in.
Hmm. So how are cities and municipalities, even in New Zealand, like how are they tracking it currently? Because I would imagine they're going out and they're doing new road surface overlays everywhere, right? That's typically what happens. We don't want to replace the concrete; we just want to put the asphalt on top. How is that being monitored?
Yeah, well, hey, if I asked you to go out there with a jackhammer and dig up your brand new road every 100 yards so you could measure moisture, are you going to go and do it?
No.
So yeah, that's right. And in specifications, you'll require tests around, on average, depending on the state or the municipality, every sort of 2 miles. All right, so they will have to go and take test pit measurements. The problem is 2 miles is an awful long way, and so you get huge variations in what's really going on there. And there's some speculation in the industry that the point measurements that are taken to date can be gamed a little bit. You know, if you get a measurement you don't like, you go 50 yards down the road, you get one that's good, and you're calling good for those 2 miles of road. So there is literally no way to get that continuous full picture of what's going on under the surface.
Tell me a little bit more into that. How are they doing it? It's like probing? Is it like what is that kind of? It sounds very archaic.
So yeah, it is. The most common technology used today is going to be a jackhammer and a microwave. So
Are
the
you
S2
serious?
standard, yeah, the S2 standard test involves taking a sample from a test pit, drying that, weighing it, and then drying it, and then weighing it again, and that's how you get your moisture content. Now, nuclear densometers can also be used in backscatter mode to measure moisture as well. But unfortunately, it's a similar situation, especially in maintenance. You're going to have to close down that section of road to be able to drop that thing down and take a single point measurement.
I can honestly say just watching different cities that I've traveled through and seeing them laying new roads, I don't envision them ever checking the moisture content under the like the. I
Yep,
don't think it's actually even written in the spec potentially, or if it
it's
is, no one's doing it.
there's specifications for moisture levels during compaction, because it's well understood how important that is. But
Okay.
other than that, there's very little. Yeah, which is part of the challenge here, right? If something doesn't get measured, then it doesn't get managed.
So I've been out driving around and I've seen companies laying asphalt on top of roadways while it's raining.
Hmm.
Is that like it seems like not shouldn't be done, right?
Yeah, that's an interesting one, and I was looking at some specs just last week as well, where a certain amount of rainfall could actually require you to rip up the entire foundations and start again from scratch as well. So yeah, I don't know whether they're quite conforming to that level of specification or not.
I mean, look, if you're spending the money, I don't know even know what the overlay would cost to lay down a mile of asphalt. What does that cost? You know?
At a city level, I think you're talking around 1.2 to 1.6 mil US per mile.
That's a lot. I mean,
Yeah.
that's wow. Okay. So
Yep.
1.6. And then if there's any moisture underneath, and I'm just kind of running this through, and it's not found ahead of time, or it's just kind of done milly willy, whatever, just get it done, right? Kind of that mindset. And then a year goes by and all that moisture, say there was moisture there, it just creates the potholes that we're talking about, like the situations where it starts to create these situations where potholes are created, right? I mean, is that kind of where we're going?
Absolutely, yeah. In
Hmm.
those climates where you're getting that freeze thaw or you're
Right.
getting that flushing occurring, that's exactly what's happening. It's causing rutting as well. So there were a couple of studies, one in the US and actually one here in New Zealand. They monitored roads. They actually installed moisture probes under the surface before they built these roads, and they monitored moisture levels over a 7.5 year period. And what they found was that the areas of the roads where they had excess moisture were failing 2.5 times faster. And they came to that same number in both studies. Moisture levels were correct. So you're taking a 25-year road and you're turning it into a 10-year road. And at that 1.2 to 1.6 million dollars per mile to rebuild it, that's a lot of money wasted.
So let me go through the construction process. If they're laying the asphalt, and let's say there's a lot of moisture left behind,
Mhm.
and no one's testing it, or if they are testing it, it sounds like there's some data manipulation potentially there.
Mhm.
That could be, now we're talking about 10 years instead of 25 years. So the $1.6 billion we just spent is going to need to be redone again in 10 more years at 1.6 or 2.6 at that time with inflation. Who
Yep.
knows?
Yep. And
Wow.
for your average municipality roads, I'd love for it to even be 10 years. Unfortunately, on a number of road types here in New Zealand, we're lucky to get them to last 5 years, right? And yeah, unfortunately, that's accepted because there is no good way to measure that moisture, right? The other ways that you have at the moment are simply not practical. So you can't blame them for that situation occurring when they don't have any other better way to do it.
So your solution obviously makes a ton of sense. Water's it's magnetic, like it's conductive. You can use electricity through it. Obviously, electromagnetic makes a lot of sense. You have the ability, your technology can drive down a road at 55 to 60 mile an hour using electromagnetic pulse, grab the moisture content data in real time, basically,
Mm,
and I would assume, and be able to determine areas of concern of excess moisture to prevent, replacement later, right? Faster, or not, extend the life, whatever
yeah,
we're
that's
talking
right.
about.
Mm-hmm.
That's
And
great. So,
as you say that, I'm reminded of an example. We did a little pilot study with the Pennsylvania DOT on a state highway area, and the engineers explained the situation. They said that this section, they had members of the public calling up in absolute despair because their children were going airborne in the school bus as they hit the joints in these subsided slabs. And the engineers were sure that this was a moisture issue, but they had no way to really prove that and get evidence that they needed to do something more here. So we went and did the scan across this, and sure enough, down to the lane where they suspected moisture was, there was high moisture there, and there were literal sighs of relief from the engineers when they're like, "Oh, well, now we can finally prove this. We could bring some data to the powers that be and go, hey." We can't keep trying to do these little patches to try and keep this area usable. We need to go in and invest the right money in doing the right drainage and the right stabilization work to fix this problem for good.
I think that's that's awesome, and that's the kind of case study we need to start using here in
Mm,
America for sure. And then my thing was, what are some of the other, because I'm thinking the design of the road, right? The drainage you kind of touched on. I was thinking this earlier in our conversation. If
mm,
it's not designed correctly, too, that's another problem because it
mm.
starts puddling on top, man. It's over. Like the water's just going to sit there and then absorb underneath. It's going to sit underneath it potentially too. Is that kind of the a thought process on some of these
That's
drainage issues?
exactly it. Yeah,
Is
and
it?
look,
Okay.
that drainage design may have been sufficient for the climate and the situation 10 years ago, right? Whenever they initially designed it, and have since just been relaying asphalt. So the other issue is that it might have been sufficient, but because the maintenance of that drainage hasn't been sufficient over time, it's simply just not working the way that it should. So these are the things we can identify. Is it an opportunity just to go and do some maintenance in the right spot there? or is it a justification for, hey, we need to go and do the right work here? Slapping another layer of asphalt on this is going to doom it to the same accelerated failure. We need to go and do the right work underneath as well.
Wow. And if we're just spending money to spend money and we keep doing the
Mm-hmm.
traditional same old things we've been doing in the past, then we continue to waste time and money for everybody. And
Yeah, that's right.
not to mention all the costs, because we didn't even talk about the repairs. I did some research before on potholes, and man, it's like 22,000 deaths a year. I think it was like
Mm-hmm.
$12 billion in repair costs of vehicles and stuff like that. This thing's massive. Like, just roads alone are very expensive for everyone in the communities and their cars and insurance companies. I would imagine insurance companies would love this in all the cities. I would hope, try and save
Oh,
some
well,
money.
that's right. That's right. I mean, if you're not the one that's had a blowout and had to make that insurance claim, you're paying through it. Your premiums going up to subsidize everyone else as well. So, yeah, it's a real problem that hits consumers directly, too.
Yeah, that's wild. So we definitely need to improve the way we're installing roads and new surface of roads and evaluate them the right way. Now, here's the tricky part. We got a couple more minutes. Does anybody really want to have accountability?
Mm, yes, that plausible deniability situation, right? And if you don't know, well, then it's not a problem you could have solved. So therefore, it's not your
Ooh.
issue. That's a really good question, and part of the challenge that we've seen is that because there hasn't been any kind of enabling technology to actually address these issues, there's not a lot of process around them. So you
Mm.
can have all the data in the world, but then what's next, right? What do you do once you actually have that information? And yeah, look, if you're paid to go out there and fix potholes, you're probably not interested in having less potholes. So there's a bit of a challenge into that as well. And it's about talking to the right people who have the long term vision, who know, hey, we need to improve the spending. We know we've got less money coming down the pipeline. We're not just going to be throwing that at new capital projects. We've got to invest in keeping what we've got good for the long term.
Well, I mean, we just do the math, right? $1.6 million we spend on a mile or whatever of a road, and we get only getting 10 years out of it now. But if we did our due diligence and held everybody accountable, and we did the project correctly the first time, now we're at 25 years. So we're
Mm-hmm.
saving, we're expanding the life cycle, the cost cycle, a cost savings analysis of this thing for lifetime value, right? Start to think
Oh,
about that.
yeah,
I mean, that's where we need to go with this thing. I mean, that's
that's right.
extending the life of
That's
the
right.
roads.
I mean,
Wow.
just imagine if you could send a guy out there digging your ditches and keeping your current drainage operational versus $1.6 million per mile of rebuilding those roads.
It's wild, man. Well, Damien,
Mm.
this has been amazing, an eye-opening conversation for sure, man. I really love it. Love the conversation. How can people get a hold of you?
Look, jumping on our website is going to be the first port of call, TDRIsolutions.com. And we've got some case studies and other information up there. We have a couple of partners in the US that can help with operations there. But equally, we'd love to have conversations directly and understand how your particular problems could be improved and solved by what we're offering.
Yeah, this is good stuff, man. Is there anything else you want to kind of end with as we end this episode?
I think, as I said, data alone is not going to solve this problem. And I think it really takes a community to develop an overall solution. But I think the opportunity here is massive that if, as a community, we can come together and develop processes around using this and take that 10-year lifetime and turn it into 25 years, we're talking about improving life for our children, for those generations that are going to be inheriting what we've left them. And I think that's really important. And that's more than just a, hey, this is cool tech. Let's play with it. It's a, how do we really systemically improve what we're doing for infrastructure for many generations to come.
Well said, man. That's the way to end this episode for sure. So thank you so much, Damien, for being here.
Uh,
Truly appreciate it and your time, and look forward to the next conversation.
Definitely. Thank you so much.
Thanks for listening to the latest episode of the Infrastructure Network.